Rows of Langstroth beehives dot the field under golden morning light. In the United States, approximately 2.8 million commercially managed bee colonies produce over 150 million pounds of honey annually. The beekeeper dons full protective gear before approaching the active hives. Each professional suit is designed to withstand over 1,000 stings without penetration, utilizing multiple layers of ventilated fabric. White smoke rises from the smoker as the beekeeper approaches the hives. The smoke masks bee alarm pheromones and induces them to consume honey, making them more docile in up to 90% of cases. Gloved hands carefully remove the hive cover, revealing frames filled with honey. A single healthy hive can produce between 30 and 60 pounds of surplus honey per season in the United States. The honey frame is inspected against sunlight to verify complete capping. Capped cells indicate honey with moisture below 18%, considered mature and ready for harvest. Worker bees are gently removed from frames using a soft bristled brush. A single worker bee produces only 1/12 of a teaspoon of honey during her entire lifespan of approximately 6 weeks. Heavy frames with mature honey are transferred to transport supers. The weight of a completely full frame can reach 6 to 8 pounds, indicating high concentration of stored honey. Honey supers are loaded onto trucks for transport to the processing facility. In the United States, honey travels an average of 450 miles from the apiary to reach supermarket shelves. Honey boxes arrive at the receiving dock of the processing plant. Modern processing facilities can receive up to 200,000 pounds of raw honey per day during peak harvest season. Frames are positioned in the high-speed automatic uncapping machine. Heated blades at 185 degrees Fahrenheit remove the thin wax layer, sealing each honeycomb cell in milliseconds. Wax cappings fall into the collection system while honey is released from the combs. Recovered beeswax represents a valuable byproduct, sold at over $10 per pound for cosmetics and candles. Industrial radial centrifuges extract honey from combs through rotational force. Each extractor processes up to 80 frames per cycle, removing 98% of honey in under 15 minutes. Golden honey cascades down the interior walls of the spinning centrifuge. Centrifugal force of up to 300 G pushes honey out of cells without damaging the wax comb structure. Extracted honey passes through initial filtration in stainless steel screens. Wax particles and debris larger than 400 micrometers are retained in this primary purification stage. Filtered honey flows into cylindrical stainless steel settling tanks. Resting for 24 to 48 hours allows micro-air bubbles to rise naturally to the surface. Surface foam is carefully skimmed from the top of settled honey. This layer contains microscopic impurities and air incorporated during the centrifugal extraction process. Tubular heat exchangers gradually raise honey temperature to 158 degrees Fahrenheit. Pasteurization eliminates wild yeasts that could cause unwanted fermentation during storage. Pasteurized honey is rapidly cooled to preserve color, flavor, and natural enzymes. Controlled cooling within 2 hours minimizes hydroxymethylfurfural formation, an indicator of thermal degradation. Industrial filtration removes impurities and wax residue from the honey. The golden liquid passes through stainless steel membranes under controlled pressure, ensuring purity without altering flavor. Stainless steel tanks store filtered honey in a controlled environment. Graduated sight glasses allow monitoring of product levels, which settle naturally before final bottling. Honey circulates through tubular heat exchangers at 72 degrees Fahrenheit. This controlled pasteurization process eliminates yeasts and extends the product's shelf life. Large homogenization tanks receive honey from different batches. Digital sensors monitor temperature and flow, ensuring uniform mixing and standardization of the final product. Sampling valves allow honey collection for laboratory analysis. Technicians verify moisture, acidity, and contaminant presence before releasing each batch for bottling. Rheology equipment measures honey viscosity under controlled conditions. The data obtained determines product classification and its suitability for different commercial applications. Mechanical agitators promote controlled honey creaming. The induced crystallization process results in a smooth, creamy texture, highly valued in the European market. Approved honey is released to high-speed automated filling lines. Modern systems can fill up to 400 jars per minute with filling accuracy of 0.5%. Golden metal lids are applied and hermetically sealed onto the jars. Precise closing torque creates a seal that preserves honey for up to 2 years without refrigeration. Automated bottling lines operate on an industrial scale. Operators monitor precise jar filling while conveyors transport thousands of units per hour. Rotating brushes and water jets clean jar exteriors after filling. This step removes honey residue and prepares packaging for label application. Articulated robots pack honey jars into corrugated cardboard cases. Each case contains 12 units arranged with protective dividers against impact during transport. Automatic palletizers stack cases onto standardized wooden pallets. A complete pallet contains approximately 80 cases totaling 900 to 60 honey jars. Forklifts transfer honey pallets to distribution trucks. In the United States, honey travels an average of 800 miles from factory to regional distribution centers.